Hello and welcome to lecture number 23 of this series. And today I will be dealing with fruity materials. And I have somewhat arbitrarily included citrus materials into this series because, after all, citrus are fruit and we're very familiar with it. Now, the first thing which is worth mentioning is that none of the synthetic materials here are in fact esters, which would be the typical type of chemical structure expected from a fruity. In flavor chemistry, as opposed to fragrance chemistry, a vast number of esters are used to get fruity notes. But in perfumery, they're not. And I suspect that it's because esters are, relatively speaking, chemically unstable. They are, more often than not hugely powerful, at least the fruity ones. And esters that are powerful and fruity are not particularly pleasant often. So it's really quite remarkable that whereas the flavors palette would be full of esters, the perfumer's palette, when it comes to fruity materials, is not. So given that I've put in citrus as well, so there's grapefruit and lemon oil, I'm going to illustrate all this with what I consider to be one of the great fragrances of all time. It's a Guerlain fragrance called Eau de Guerlain, composed in 1974 by Jean-Paul Guerlain. And if there is a better citrus fragrance out there, I am not aware of it. And what I find absolutely wonderful about this fragrance is that it's as if it uses all the different fruity facets. I mean, a lemon, but also a lemon balm, lemon verbena, mandarin. There's an extraordinary complexity in what is normally a fairly simple note. I mean, when I smell lemon oil, I feel it's like a guitar string being plucked. It's a ding of perfume, whereas this is like a mandolin. It's as if you doubled the strings and you get the ding, 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 ding. And it's also long-lasting, which is really remarkable, considering that most citrus materials are what are called top notes, and you wouldn't expect them to go on for more than about half an hour. In fact, the most famous citrus composition is, of course, Eau de Cologne, Acqua di Cologne, Kölnisch Wasser, which was figured out, at least in part, by an Italian perfumer working in Germany in the 1720s, I believe, and which is a citrus composition, citrus and rose, and it's led to a lot of variations, but the basic citrus idea in fragrance is eau de cologne, and in fact in the US many people use the word cologne to describe perfume in general. The remarkable thing about eau de Guerlain is that it's not that sort of fresh thing that you splash on and then basically by the time you get to your car or to your work it's just gone. This thing actually will last most of the day and smell great. It's technically an extraordinary achievement. I have absolutely no idea how it's done. So that is, I think, one of the best citrus notes you can find. So let me just transition from that to one of the two citrus materials we have here, which is lemon oil. Now, lemon oil is pretty much what its name indicates. It's the oil from the peel of lemon, and it's mostly citral, which is a 10-carbon aldehyde, and a lot of other secondary molecules, I imagine pinene and all sorts of more resinous things that tell you lemon. When you smell citral pure, yes, it is lemon, but it does have a sort of something bare and functional about it, whereas lemon oil really is rich, and you can practically see the lemon in front of you. It's actually amazing how close it is to the smell of freshly, if you take a lemon and you scratch it with your nail. Now, citrus oils come from all over the world now, but the original citrus oil producers were southern Italian, and still are. They're very large, successful firms making them. And I heard once a rather funny anecdote about a famous, really famous French perfumer, very senior and important French perfumer, who went down to buy some lemon oil to check out the quality down in one of these firms in southern Italy. And they played a trick on him, which was to pretend to be showing him different batches of lemon oil. And in fact, it was always the same batch. They just put it in a bottle with a different number. And he smelled them all, and then he said, that one is much better. And they're still laughing about it. But that illustrates the fact that at the extreme limit, which is the job of choosing an exact quality of raw material, which is what technical perfumers do in the big firms. They have 20 different batches of lavender or tuberose or lemon oil indeed, and they have to decide which one to buy in order to keep the quality of the perfume constant. Now, those guys and women have incredible noses, because if you're smelling lavender all day and you're still able to by nose to remember that batch 1174 was actually the really good one, and that's what we need to keep that quality constant, etc. You're really something. I mean, that's, to my mind, that's on the level with wine experts in terms of both smell discrimination and smell memory. It's really, truly remarkable. I certainly couldn't do that. The other oil I have here, which is a natural, is grapefruit. Now, grapefruit differs from lemon in many, many ways, even though we think both of them as, of course, citrus, but grapefruit is a really different smell. And one of the things that distinguishes grapefruit is the presence of very small amounts of a sulfur-containing impurity. I'm talking minute amounts. And one of them is a pinene structure with a sulfur attached. And of course, if you smell it pure, it smells hideous. The usual sulfur smell, so-called rotten eggs. But if you add a microscopic touch of this pinene thiol to, let's say, orange oil, you get a pretty convincing grapefruit. And in fact, this game of taking citrus oils and modifying them by addition of small amounts of stuff has been played in perfumery for a long time. Now it's harder to do because people have very good analytical chemistry capabilities. But there's a famous story of the great French supplier of raw materials. Delaire discovered that by taking orange oil and adding, I believe it was 0.1% birch tar and 0.1% galbanum, very green note, he got a really good mandarin. And apparently, Delaire just basically took drums of orange oil, added these two tiny amounts, changed the label to Mandarine Delaire, and sold it for 10 times the price. And made a ton of money, I imagine. And you couldn't do that today because the chemists would probably know immediately that you had done it and that you were, pulling a fast one. But in the early days of perfumery, that was the difference between a successful firm and an unsuccessful one. So the first of these synthetic materials that are fruity is a molecule called aldehyde C16, and it's not an aldehyde, and it's not a 16 carbon. In fact, it's a 12 carbon molecule. I was a bit unfair, actually wrong, when I said that none of these were esters, because this is a glycidic ester, which is a peculiar structure with an ester linkage and an epoxy, a three-membered ring with an oxygen next to it. And this one is indeed fruity, and this thing is called strawberry glycidate. And I'm sure everyone has noticed how unconvincing strawberry flavors are. When you see chewing gum or many types of cheap ice cream that are labeled strawberry, and you taste them, you find that it's not strawberry at all, and that's because they're using this thing as a strawberry flavor. And it is fruity, it is powdery, it is pleasant, it is generally speaking the right color and tone, but it's absolutely not a strawberry. It's nowhere near strawberries. I think when it was first discovered, these glycidic esters are very old. They're from the early 20th century. When it was first discovered, it was considered a good enough approximation. But right now, it's only just I think, a very small part of a decent strawberry flavor, certainly. And in perfumery, it's a rather abstract, fruity note. So now we enter the realm of, let me put them in what I think is chronological order. We enter the realm of synthetic aroma chemicals that happen to give a fruity effect. And this is frambinone. I pronounce it in French because framboise is raspberry in French, so I can't, that word comes out in French. Now, I can just imagine, I wasn't there of course, and I don't even know who did it, but I can just imagine the lab in which this molecule was discovered. Because what happens in a fragrance chemistry lab is that when you, usually by chance, happen upon a very powerful aroma chemical with a given smell, is the entire lab smells of it. Because no matter how careful you are and the fume hoods and everything, there's always, with the powerful ones, there's the stuff is everywhere, even in tiny amounts, and you can smell it. And I just imagine that when they discovered frambinone, the entire place must have smelled of raspberries. And raspberry to me is such a vivid color. I mean, it, you know, in French they say fruit rouge, meaning red fruit. This is a red smell, and I can just imagine the chemist calling up the chief technical perfumer and said, "I think you should come over here and smell this, because it's really quite extraordinary. It's a really good, soft, saturated raspberry smell." Now we're moving into really abstract fruity categories that are no longer, I think, easily referenced to something familiar from the street market. And this is paradisemide. So it's an amide, which is found in paradise. And it's very fashionable at the moment, after being neglected for decades. Amides have become a staple of niche perfumery. They smell of rhubarb. And rhubarb is a rather ambiguous smell if you think about it, because it has what I would describe as an animalic aspect. I mean, it smells very much like a horse fur. It also smells a little bit of celery. And on top of that, it has a pleasant acid, sour, mouth-watering feel. So you can see, when you find a material like this that has all these different facets, the more facets, the better it's going to get on with other stuff. It's a little bit like a game, like a tangram, where things have to be fit together. This guy has, you can smell, you know that a perfumer is going to be interested in this because it can go in a variety of different directions. So the next fruity material which I have here is pharaon, as in the pharaoh, but with a ketone attached to it. I don't know what it is about these fruity things. Paradisamide and pharaon, my goodness, we're getting into really superlative names. This is fairly recent and quite powerful. It's at 10%, and I can smell it from there. Wow, that's powerful. Now, is it fruity? It's classed as a fruity, definitely. What kind of fruit is it? I honestly, I'm going to go and consult the catalog. So I'd never smelt pharaon before, actually, certainly not pure. And I had to go and look it up to find out what people do with it, because it's not in the least bit what I would describe as a fruity note. It's a sharp, herbaceous, slightly dirty, and with a peppery angle. And I went and looked it up in the good sense, and apparently it's used in pineapple and in a variety of other, including citrus and herbaceous accords. And if I were the perfumer, and not a very good one, and the chemist came to my office showing me, oh, look what we found, what do you think of this? I would say, it doesn't smell good. And in fact, I would be completely wrong, because this thing, although it doesn't smell particularly good or particularly distinctive or particularly fruity or particularly anything, precisely because of that, is going to fit in a variety of compositions. Now, people have to figure this out. Someone has to figure out how to use it. And they start making what are called habillage, dressed up versions of the molecule itself. And that is an art entirely separate from the composition of perfumes. It's a very different conceptual thing. And the last material today is called Sauvignon 100. And it is manufactured by the great Japanese fragrance firm of Takasago. And whoa, that's powerful. And it's named after the grape varietal Sauvignon, I imagine, which is used in particular in some extremely fragrant white wines. Whoa! Okay, so this is a classic. First of all, it's a sulfur molecule, contains sulfur clearly, because it has, apart from a fruity green aspect, it has an intense, freshly cut onion note. But oddly enough, for an SH molecule, the overall effect is actually, in the middle distance, quite pleasant, which is very unusual. It's almost like the rest of the molecule has managed to hide the SH effect. If you drink a Sauvignon Blanc wine, typically the best ones, in my opinion, in this particular style are from New Zealand and South Africa. You do get this note, but I would never, while drinking the wine, have described it as oniony. This is also a very good illustration of the fact that sulfuraceous notes are essential to get a really good 3D fruity effect very often. One experiment that you can do at home, if you have access to fresh strawberries, you put them in a blender with ice and you blend them with the lid on. If you take the lid off and you smell the strawberries, the note that you get is hard-boiled eggs. And this is because there's a low molecular weight sulfur compound in strawberries, I don't know which one it is, that is essential to give a true strawberry flavor. And it's actually remarkable that you can actually do that completely independently. You can buy, in many countries, certainly in England, you can buy a type of salt called kala namak, which comes from India, which means, I believe it means black salt. And it's a salt which contains sulfur as an impurity. So in blocks it's black. Once you grind it, it's pink. And if you touch your finger to kala namak and lick it, you get a very powerful, I suppose, hard-boiled egg smell. But if you take a fruit salad and you sprinkle a little bit of kala namak on it, it becomes, it's still a fruit salad, but it's an enormously better fruit salad. So there's a funny thing there that a touch of a rather unpleasant smell gives tremendous intensity and depth to a variety of fruity notes.